Now, the reason, and you don't know this because you're not playing it, but the controls, it seems to slide. When I let go, the paddle keeps moving for a little while. Actually, the longer I've held it, the more it seems to keep moving after I've let go. And the reason is this axis, the horizontal and vertical, are really meant to simulate a really kind of analog kind of control. And it doesn't come to a dead halt instantly when I let go of the key. It sort of slowly drifts back to the middle position of the axis and then it stops moving. And that is controlled by the gravity parameter. You can see here for jump, the gravity is set to 1,000, which is effectively infinite for this purpose. If I do that, the same thing here, then when I hit go, it does instantly stop when I let go. And there's a variety of little tweaks and things you can fiddle with here to get the exact correct performance that you want. You can also split the axis so that the keyboard control is not also exactly the same parameters as the joystick control. You might want to break them apart, but for our purposes, this should probably be fine. Oh, that was an undesirable behavior. Interesting that it's sticking there. I think that would still have to do, because they don't have friction. We have that completely turned off, set to average. Guess we'll just set it to minimum. But almost certainly that has to do with our physics setting. We're going to set the bounce threshold to very low. Because we, in fact, I don't know, maybe we can just put a 0 here. Because we always want it to bounce. Doesn't matter how slowly it's going relative to the wall, we always want it to bounce perfectly. There we go. That's probably a better tweak. Now, one other thing that I didn't do exactly ideally in here. The axis, like I said, returns this lesser than or greater than 0 based on the direction, but it also returns a certain magnitude. And one other way of implementing this, especially if you're using an analog control like a joystick and you want to move very slowly to the right as opposed to cramming the joystick all the way, which means you want it to move a little faster, or at least to your maximum speed, is we could have actually rewritten this as, just grab that, whoops, 10f times time delta time times the value returned from the axis. If we're not moving the joystick or hitting the key on the keyboard, that's going to return 0, so it won't move at all. Otherwise, it's going to be tweaked based on the magnitude of the movement. And that's going to affect our numbers quite a bit. I suspect that things... Oh, no, they're moving okay. It takes a little second to start up, and I think that's probably because of the sensitivity. If we max out the sensitivity here, it's probably much closer to what we want to experience. Yeah. Now it feels perfectly responsive. Exactly what I would do with the keyboard. Now, how that's going to translate to joystick, I don't know. You're going to want to test that. And again, you may just want to split it out. You can see, actually, it already has a second horizontal axis over here, which I don't know, the fact that it's got the same name. Well, this one's not bound to any keys, so that's part of it. But you could take the keyboard bindings off of the first one and just move them down here, and then use separate gravity and sensitivity settings for both of those, and then you would be perfectly fine. That being said, I'm pretty happy with how things are now. Feels pretty good. Now, one of the things that the Breakout game has is based on where the ball hits the paddle. It adds kind of a little bit of an English to it. You can control the direction of the bounce. You can make it go more, say, if I hit it here, on the bounce back, it should go more to the right. The angle, it won't be a perfect reflection. It's almost like you could imagine the top of the paddle is curved. That's kind of how it works in this game. And also, usually if you're moving, it should affect the ball as well. So there's a couple ways we can implement that. One, we could actually go into our 3D modeling program and model this to be curved. And either make that visible, or we could even make that model invisible, but still have that curve there, and literally still use the physics engine to calculate the perfect reflection. And to make it really smooth, we'd want to have lots and lots of polygons. And in practice, I'm not sure if that's the best. It's also hard to tweak in gameplay if you're not quite happy with how things are. Instead, what we're going to want to do is when the ball hits the paddle, we're going to want to catch that collision event and then apply a little bit of force in either the positive or negative X direction based on where the ball hit the paddle. So we're going to flip over here, and we're going to keep doing this in the paddle script. And we're going to add another callback here. And these are callbacks that are automatically triggered when the program runs. It's going to be void on collision enter. And I don't know, I'm not getting an auto completion here. I think it's collider. No, maybe not collider. Collision. Let's see what that does. I always do this sort of thing. If I'm not sure what something does, let's just output some data. Bam! No? Alright, it's definitely working. When the ball hit the paddle, it fired off a collision event immediately, which is fan-frickin-tastic. So, what we want to do is we want to know exactly where we got hit. So, in our collision object, we have our contacts, which are the place where we got hit. And I guess we want to enumerate these. I'm going to have to look this up to get the exact syntax here. And I'm going to do that by Googling Unity collision reference. Script reference, collider on enter collision. That's exactly what I want. Let me pull that over to our view over here so you can see what I'm looking at. So the Unity manual is very easy. I always just Google Unity and then what I'm looking for, and I tend to find it, and usually a lot of forum entries as well, posts that people have questions or clarifications or special cases. So you can see an example here. We're going to change the language over to C#, which is what we use. And that's exactly what I'm looking for. So I had this right. For each contact point in this, well, it's going to draw a debug ray. That's not what I necessarily need. And now I just want to go back over here. So for each contact point contact in our collisions contacts, do something. Perfect. Contact dot. So we want to know the point of contact, but we want to know it on our paddle. So what we're going to do is we're looping, because this is going to generate 2 points of contact, one on the paddle and one on the ball. So we're going to loop through the contact points, and we want to say, okay, the contact of this collider, if the contact of this collider is equal to our collider, which is our box collider, then we know we have the paddle object. This is the paddle's contact point. So now we'll know where on the paddle we are.